This is Mr. Beck Does Your Homework. This is AP Physics Homework 5.3, question number 5. A mass of 1660 kilograms is held on a frictionless surface 7.7 meters from a second mass of 166 kilograms. So this is the first mass, 1660. This is the second mass, 166. The surface is slowly tilted. At what angle of inclination will the second mass begin to slide down the plane? And this says your coefficient of friction is 0. The acceleration of gravity is 9.8 meters per second squared, and the valuation of the constant is answering units of degrees. So this is a frictionless plane. So what this is saying is that I'm going to have, on this mass, I'm going to have a force of gravity this way, a normal force of gravity. I'm going to have a universal force of gravity this way towards this mass, and I'm going to have a normal force pointing this way. It's my normal force. Well, I know that gravity in this case is going to be my monster because this mass is going to start sliding down. So gravity, let me draw that this way. My gravity is going to be made up of a force into the plane and a force down the plane. So this is my Fg. This is what I call Fg down, and this is what I call Fg in. Now I know that with that mass, with Fg in and Fg down, now I've got that mass sitting on the plane, and it's got a force of gravity down. This is the component, Fg down. It's got a component in, Fg in. It's got a normal force this way, and it's got a universal gravitational force this way. Well, the in and the normal, those are going to cancel each other out. So what this is really looking at is at what angle will this gravity down the slope equal the universal force of gravity. Well, this gravity down, since this is theta, just like this is theta, this one's theta, so gravity down is going to be the opposite, is going to be sine. So Fg down is going to be mg sine theta. And when that equals the universal gravitational force, that's g m1 m2 over r squared. What I know is that this mass down here is this m2, so this is going to be 166 kilograms. This is the m1 of the top one, which is 1660, and this is m2, which is the 166 again. So this m2 can go away with this m, and this is the bigger m. So I get g sine theta is going to be that. So I know that the sine of theta is going to be g times the mass 1 divided by little g times r squared. So the angle is going to be the angle whose sine is. It's the inverse sine of over that, all of that. So theta is going to be the angle whose sine is g, which is 6.67259 times 10 to the minus 11, times my bigger mass, which is 1660, divided by g, which is 9.8, divided by r squared. And r here is, careful, it's millimeters, 7.7 millimeters. So 7.7 millimeters times 1,000 millimeters in 1 meter will give me 0.0077 meters. So that's what I've got to put here. And don't forget to square it. So the inverse sine of ba-bump, ba-bump, and you get yourself a theta.